Today we are going to discuss about instrumentation. Along with me, Mr. Srinivas, senior lecturer, is also accompanying, and both of we will discuss about this instrumentation. What is instrumentation? So before going to instrumentation, let us take an example. How are you? I am well. So well means how much? Is there any measurement for it? So if a particular person is sick, how much well he is? In the same way, when we come to the engineering applications or designing or anything, we need certain measurements. So for that measurements, we need certain instruments. So anything which we are going to design or manufacture need these instruments. So we are having lot of devices or instruments, but we are limited to certain things which are applicable to our subject concern. Now let us go for what is instrumentation. So instrumentation, how it can be defined. So instrumentation is the branch of science which deals with the study and design of various instruments and devices used to measure a number of parameters like pressure, volume, temperature, heat, etc. in the field of engineering. Let me study once again. Instrumentation is the branch of science which deals with the study and design of various instruments and devices used to measure number of parameters like pressure, volume, temperature, etc. So it is a device which measures. So what is that measures? Pressure, volume, etc. When it is going to be designed. So when we are designing a particular component, we have to go for this instrumentation. So in this we are having lot of parameters, not only pressure, volume, temperature, etc. There is stress, strain, deflections, a lot of engineering applications are there. All those things can be done. Now, but these instrumentation, when we go for it, before that, what are the instruments? So these are the devices. So they are called instruments. So what is an instrument, or what are the instruments available for us in this instrumentation? So an instrument is the device which are used to measure and record the parameters are called instruments. So the devices, which are used to measure and record the parameters are called instruments. For example, to measure. So what is today's temperature? Say it might be 32 degrees. So that is a measuring. Then we have to record it. So for recording as well as for measuring, we need this instruments. So this number of instruments that we are going to use, it comes under instrumentation. So without the instruments, generally we may not go for the instrumentation. So we are using lot of instruments, so that we will go to the science of this instruments, which is called instrumentation. Now let us go for what are the functions of instrumentation. So what it does: provide guidance to operate the plant efficiently and economically. So provide guidance to operate plant efficiently and economically. So a particular plant is there, whether how far it is good. For example, you can take our performance, student performance, whether he got 60%, 70%, 80% or 40% fail, all these things are performance. So how to go for a plant efficiency? That comes through instrumentation, because through the instrumentation we record different temperatures, different pressures, different volumes, etc., so that we will get the efficiency. The next one is use it to check internal conditions of the equipment. So what is the internal condition of the equipment? whether they are good or bad, or what temperature inside it is, or what pressure inside it is, etc., can be find out. That is internal conditions of the equipment. Next, enable economic supervision. So supervision can be done, but economical, with less cost, with less safety condition. That is whenever we go for different complicated things. Then help in plant performance calculations. So what is the performance of the plant? For example, you can take thermal power plant. So what is its efficiency? 70%, 80%, 90%, like that. So how to calculate this performance? That is through instrumentation. The next one is help in accounting and cost allocation. So what is how much amount should be allowed for particular department or for a particular equipment? Then we need this thing. And again we have to accounts, maintain the accounts also. This instrumentation is needed, particularly in the thermal power plants. Okay, right. Now these instrumentations, can we go for any classifications? Is there only one instrument or different instruments are there? Definitely there are large number of instrumentations. There can be large classifications, but we limited to only two things, mechanical and electrical classifications. Right. Now first one is mechanical instruments. So what is this mechanical instruments? Measures mechanical quantities such as temperature, pressure, flow, etc. So these mechanical instruments means which measures mechanical measurements. And next we go for electrical instruments. So in electrical instrument measures electrical quantities such as current, voltage, power, etc. So current, power, voltage, etc. to measure, we go for electrical instrumentation. So we are limited to these two only, but there are lot of things, electronics as well as optical, and so many things are there, but we are limited to mechanical and electrical. Now the first one is we are having lot of devices, instrumentations based on mechanical as well as electrical. But what are the things that we are going to discuss today? So we are going to discuss temperature measuring devices, pressure measuring devices, and smoke detectors. So these three we are going to discuss today. So temperature, pressure, and smoke detectors. Now first let us go for what is this temperature measuring devices. So how do we classify temperature measuring devices? So expansion thermometers. So again in this expansion thermometer, solid thermometer and liquid thermometer. Next is electrical resistance thermometer, electric pyrometers. So in this case, if you see expansion thermometer, solid thermometer, there is this bimetallic where we go for higher temperatures, we go for this, and liquid thermometer, this mercury, which normally even we get the temperature, we measure this. These low temperatures are there, then we go for this liquid thermometer. Electrical resistance thermometer, through the resistance we will find out, and thermoelectric pyrometers. These are pyrometers are nothing but again it is also thermometer, but which used for measuring high temperatures. These pyrometers are used. Now let us go for detail about each thing. So what is thermoelectric pyrometer? So as I said, so first is what is pyrometer, then we can go for what is thermoelectric pyrometer. So what is pyrometer? Pyrometer is the term used for thermometers meant for measuring very high temperatures. So measuring very high temperatures above 350 degrees centigrade, it is better to go for pyrometers. That is up to 1600 or even 3600 also, it is better to go for pyrometers. Below 350 it is a thermometers, above that pyrometers is best suited. Now what are the examples? Furnace, molten metal bath, superheated steam. So in the furnace, what is the temperature? that can be measured with thermometer as well as a pyrometer, but it depends on the temperature of the furnace. In the furnace, if the temperature is more, then we go for pyrometer. So generally in the furnace the temperatures will be normally about 1200 or 1000 or like that. So instead of thermometer we use it a pyrometer. Next one is a molten metal bath. When we go for castings etc., certain metals will have certain different melting temperatures. Based on that we have to go for pyrometer, because generally all the melting temperatures of the metals will have more higher, so that we go for pyrometer. Next one is superheated steam. So again in thermal power plants, when the power is going to be produced, means the water is converted into steam, and that steam temperature we have to measure again, that it will have more than 350 degrees centigrade, then generally we can go for using this pyrometer. Right. Now what is thermoelectric pyrometer? So far we have studied what is pyrometer. Now we go for what is thermoelectric pyrometer. So principle of thermoelectric. So here when we go for a thermoelectric pyrometer, another thing comes is a thermocouple. So when the conductors of two different metals are joined at one end, and when this junction is heated to a high temperature with respect to free ends, an EMF is produced at free ends. When these free ends are connected, a flow of electric current is established. So again, when conductors of two different metals are joined at one end, and when this junction is heated to a high temperature with respect to free ends, an EMF is produced at free ends. So let me explain this. So when we take two wires with different materials, and they are being joined either by brazing or welding or soldering or even just simply twisting, then when these two are connected at one particular joint and we go for heating. So at that particular heated to high temperature, then what happens? EMF is generated at free ends. So this EMF generated, because of this EMF current will be generated, and if this is connected to the voltmeter or ammeter etc., we can find out what is the EMF generated or what is the power generated or current generated. Again, when these free ends are connected, a flow of electric current is established. So when these free ends are there, EMF is generated, and these free ends are connected, then electric current is established. This is being identified or invented by Seebeck. So hence it is called a Seebeck effect. Now there are another effects based on this Seebeck effects. Two effects are there. Let us study about these two effects. Based on that we will go for the what is thermocouple. That is, if you want to go for thermocouple, first we have to see what are these effects, and based on that we will go for the thermocouple. Now first one is what is a Peltier effect. So I told you two effects are there. First one is Peltier effect. The EMF produced is due to contact of two dissimilar metals, and its magnitude varies with junction temperature and metal forming the junction. So here EMF is produced, this was explained in the earlier previous thing, is due to contact of two dissimilar metals, metals which are having different metals, that is two wires are not having the same material, and its magnitude varies with junction temperature. So how much current is produced or how much EMF is produced, it depends on the magnitude. That magnitude varies with junction temperature. How much temperature that we have given in the, or how much heat we have given at the junction, and what are the materials we have used for that particular wires. Based on that, what are the wires we have used, what materials of the wires we are used, based on that how much current is produced or how much EMF is generated. This is called a Peltier effect. The next one is Thomson effect. So what is Thomson effect? the EMF produced is due to temperature gradient dt by L along the conductors in the circuit. So, the EMF produced is the temperature gradient along the conductors in the circuit. So, temperature gradient, that is difference in temperature, and along the circuit, that is what is the length of that particular circuit, that is called the Thomson effect. Next is, when out of these two, Thomson effect is quite small and less relative to Peltier effect. So, this Thomson effect is quite small and less relative to, so small and less relative to Peltier effect. Now, with these two effects leads us to define what is a thermocouple. Based on the Peltier effect, based on the Thomson effect, we have to come now what is thermocouple. Right. Now, the two Peltier and Thomson effects forms the basis for very important temperature measuring element called thermocouple. So, based on these two very important temperature measuring element. So, thermocouple is used for measuring the temperature based on these two things. Now, let us see this principle of thermocouple. Here, these are two wires, dissimilar wires. This is one wire, this is another wire. These two are joined together here, either soldering or brazing or even simple twisting, and here we are making it heating. So, when heat is given here, so here the expansions will take place or whatever it may be, and EMF is generated. Here this is a cold junction and this is being connected to the millivoltmeter. So, when these two are connected, then because of the EMF generated here, the current will be produced here, that current will be measured or in this particular millivoltmeter. So, this is about principle of thermocouple. Now, if you see here, when we go for this the same different reading thermometers, distant reading thermometers, in certain cases when we go for measurement of temperature device is in a furnace. So, if we want to go for measuring the furnace temperature in the furnace, we can't go inside the furnace or even at the nearby the furnace and can't see it. In such a case, the measuring device will be at some place and actual furnace is in some other place. So, in these two will be somewhat distance we have to maintain, or even if you go for a particular thermal power plants, we can see certain control room is there, where we can find out all the temperatures, how much power is generated in a control room which is very distant. In such a case, these type of figures, these type of thermometers are used. Here this can be put inside, and here we can sensing the bulb, so that we can find out. This is another type of thermocouple for a distant thing. Next, based on this thermocouple principle, now let us go for what is thermoelectric pyrometer. So, that is the basic thing which we have to go for studying this. Now, if you see here, so this is one, this is a hot junction, that here if you see, this is nothing but a thermocouple. This thermocouple is connected to the voltmeter. Now, here this is a hot junction, these are insulations or insulators, this is a sheath. So, what do you mean by sheath? For what purpose? It is protection. For what? For mechanical obstructions, for some other oxides, etc., when we have to go for measuring inside the furnaces or anywhere, for protection due to mechanical things or electrical or heat, anything, and these are being insulated, so protected from oxidation. And here compensating leads. So, these are compensating leads, and this is a cold junction. Now, here if you see that if we go and put this inside the furnace, we can find out what is the temperature inside here, that is through the voltmeter. So, this is a principle of or explanation of this thermoelectric pyrometer. Now, whatever this we have seen, there are different types of thermoelectric pyrometers which are given in industrial. That is, in industries there are lot of varieties are there. It can be in a furnace, it can be in a oil furnace, or it can be in a molten metal, etc. Now let us see the examples of this, how they are going to be used. Now see, this is thermoelectric pyrometer which is used for molten bath. So that is a molten metal. Particularly, for example, when we go for a casting, we have to heat the metal and it is in a melting state. So what is its temperature? At what temperature it melts? Up to that temperature we have to heat it. So this is the another thing is, this is in oil furnaces. So the thermoelectric pyrometers are kept in oil furnaces. The next one is, this is in a furnace. In the furnace, how to keep this pyrometer and its applications, various industrial applications in this particular thermoelectric pyrometer. Right. Now let us go for one more figure of this thermocouple pyrometers. Now here if you see, these are the iron, constantan, copper. So copper rods are there, and constantan is, this is another particular metal which is a combination of two metals in percentage of 60 and 40%. And here next is a resistance thermometer. So the second part is resistance thermometer. So through the resistance we will measure the temperature. So thermometer is nothing but to measure the temperature. So how to measure it? Through the resistance. So we have to create our resistance should be developed. Based on that, how much resistance has been there and how much it is going to be produced. So what is resistance thermometer? Principle: electrical resistance of metallic conductors increases as temperature increases. So electrical resistance of metallic conductors increases as temperature increases. So these metallic conductors, whatever it is there, when the temperature increases, resistance also increases. This is the principle. When the temperature increases, resistance increases. Based on this, we have to go for this resistance thermometer. It is made of platinum and copper. So what are these conductors? Conductors are made of platinum and copper, iron, nickel and their alloys. So here if you say take a platinum, at different temperature we go for platinum, at some other temperature we go for copper, and some other temperatures iron, nickel and their alloys. So based on the temperatures what that we need, based on that whether we can go for platinum or copper or iron or nickel or its alloys. So based on temperature requirements we go for different types of metal. Right. Now we have given certain materials, resistance thermometers. For those materials, can we use any type of material? That means, say for example, you can take an easy example. We want to use a particular bulb for study purpose. So what type of bulb we are going to use? It depends on one person or 10 persons, or it is in a hostel, like that. So if only one person is studying, we can go for just a table lamp which is 15 watts is more than enough. But when 10 people are studying, that the same 15 watt may not be enough. In such a case also, here also we have taken different types of materials based on different temperatures. In such a case, whatever the temperatures or whatever the materials we take, we cannot take as it is. But when we take a particular thermoresistance thermometers, the material should have particular properties. So what are those properties? What type of properties that material should have? High thermal coefficient of resistivity. So the material should have high thermal coefficient of resistivity. Second one is corrosion resistance. So that conductor materials should be corrosion resistance. Next, ease of fabrication. When we go for fabricating or manufacturing, it should be easy. Phase stability. When it changes the phase, stability should be there. Right. Now see, it is an electrical resistance thermometer. There are two types of thermometers. This is one type of thermometer. It is a tip type thermometer. Here if you see, this is actually solid the thing is this is a core which is called solid silver core, and these are the resistance windings. So here these are the windings. These windings are wound around this solid silver core, and here this is a sensitive capsule which senses the temperature, and here there is a insulator, that is ceramic insulator, which cannot insulator means which stops the temperature, or which cannot transfer, which stops the transfer of temperature. And here these are the extension tubes, and here this is the leads wrapped with glass fibers, and these leads are connected to a voltmeter or millivoltmeter, and so that we can find out what is the electricity or current or electrical resistance produced. And these two are the extension tubes, because this might be in some other furnace which are at distance, so we cannot go for measuring here. In such a case we go for this electrical tube. So this is one type of electrical resistance thermometer. Now here if you see, number of turns of resistance wire wrapped round a solid silver core. So as I explained, these number of turns. So if you see, if you remember the previous figure, there are holes which are the cross section of that turns. So there are number of turns of resistance wire wrapped around the solid silver core, and heat transmitted quickly end flange to the winding through the core. For example, if you see again the previous figure, here if you see one end, it is transferring to one end to another end. So in such a way this transfer of thing will be taken place. Next is another type of resistance thermometer. Here if you see, this is the spring, this is the shell, and here these windings. These windings are wounded around the mica plate, and in between these windings it is sandwiched with the two mica plates, and these mica plates are in between the springs, so that it is shielded in a shell. Wire is wrapped around the mica strip. In the previous case, wire is wrapped around the solid silver core. Here it is around mica strip. Next is sandwiched between two additional mica strips. It is sandwiched between two mica strips. Next, use it directly. So there is no other extra intermittent things which we can directly use it for measurement of temperature. Enclosed by the basic tube or sleeve. So again, for mechanical or electrical or some other distractions or protection, we go for it is enclosed, and the temperatures of -40 to 550 degrees centigrade can be used in this particular thing. Next is platinum resistance thermometer. Another type of resistance thermometer is a platinum resistance thermometer. So this platinum resistance thermometer, again the same principle, but here we are giving different types of things. And here what is that we are going to make is, these edges, this C1 and C2, P1 and P2 are given to another bridge which is called Wheatstone bridge. I think you might have known this bridge in your electrical technology or even in 8th class, 10th class, etc. So these ends are connected to this Wheatstone bridge, and we will measure the things. Let us see what is this platinum. Platinum wire free from impurities. So in this platinum resistance thermometer, we are using a platinum wire which is free from impurities. What are those impurities? Silicon, carbon, copper, etc. Whatever it is there, they should be removed. Then doubled itself and wound on a thin plate of mica. So these wires are wound on thin plate of mica and enclosed in a glass or porcelain tube, that is as for protection of the mechanical things. And the tube is evacuated or filled with dry air or sealed, that is put into the vacuum or dry air in the things. Next, compensate resistance leads. So whatever the C1, C2 are there, they are compensate resistance leads, they are connected to the Wheatstone bridge. Tube is sealed at the top to protect the coil from the moisture, and this tube is going to be sealed. So because of the moisture existing, it may spoil the thing. Temperature of the space is proportional to the resistance of the platinum wire. This is important thing, that is, what is the temperature producing? If the more temperature is producing, means the resistance is more. So this is directly proportional to the thing. To find the resistance, a modified Wheatstone bridge, that is called calendar, and a Griffith bridge is used. So anything, either Wheatstone or Griffith bridge, anything can be out of these two, we can use it and we can measure the things. Now let us see another figure of this resistance pyrometer, another type of this, the same as explained it, but in different things. Next is how to calculate the temperature in this. So the temperature is calculated, RT is equal to R naught into 1 plus X into Tp, or this can be called as alpha. Not only X, it is called alpha, where X is mean temperature, coefficient of resistance, and R1 and R naught, RT and R naught, RT and R naught are the resistance at 0 degrees and Tp degrees of temperature. Now what are the advantages of the measurement is accurate. Constructional flexibility, we can go for not rigid, that is, we can change the designs. Possible to operate indicators or records or controls. Resistance elements can be easily installed and replaced. So resistance elements can be easily installed and replaced. Whenever we have to install or whenever we have to replace, it can be done easily. Next, continuation. Easy verification of results. Results can be verified whether they are correct or not. Differential temperature measurement is possible. Least variation in the temperature can be measured here. Wide working range, at different temperatures we can go for it. The temperature ranges are different. Suitable for remote indication, that is, at a distant place we can go for it. Response time is 2 to 10 seconds, that is, within 2 to 10 seconds we can find out what are the temperatures. Okay, not only all the advantages, there are also certain disadvantages. First one is high cost, second one is need for power supply for bridge circuit, that is, the cost is more. Second one is we are connecting Wheatstone bridge, so which again it needs certain power, so it is a extra cost. Now Mr. Srinivas will go for the remaining topics of thermometers, that is bimetallic thermometers, and how it works and what are the different types of things. Mr.
Now about a bimetallic thermometer. The name itself is indicating that there are two kinds of metals that are just joined, and then if they are heated they will expand depending on their linear coefficients of expansion. We can see the working principle involved in the bimetallic thermometer. The working principle goes like this: two metal strips bonded together differently will expand differently when they are heated due to the difference in coefficient of linear expansion of two strips. I repeat, two metal strips bonded together will expand differently when they are heated due to the difference in coefficient of linear expansion of the two strips. The two metals that are selected are different. Obviously, their coefficients of linear expansions also are different. So when they are joined and put to that hot environment, then they expand and show the difference in their coefficients of linear expansion. That is, the amount of expansion will differ. That will be read, or that kind of movement will be read as a temperature. That's how it is recorded. You can see this diagram. In this diagram, there are two strips of metals, that is called bimetallic strip. Now the two strips will be joined, and according to the coefficient of linear expansion, which one is having more coefficient of linear expansion, in that direction the metallic strips deforms or gives a jerky movement. This is how we can, this particular movement can be used for the recording of such temperature. you can see the diagram. Here in the diagram you can see the casing, you can see the fixed end and the transmission spindle, the third one. Now the helix, the two metal pieces are deformed or taken the shape of an helix. 5 is a pointer, the end view of the pointer you can see it is in the spiral form, that is again a metallic wire, and here when we come back to this diagram it is guides, the guideways are given, the guides are given. Now the fixed end too is connected to the hot environment, as a result of which the two metallic strips which are in the helical form, they will expand or deform due to that hot environment, that is heat is transferred to them, and as a result of which the expansion or deformation in the strips is being transferred to the pointer, and the pointer moves or swivels, which will be read as a temperature. For example, you can see this diagram, bimetallic expansion thermometers. You can see the cold junction and you can also see the hot junction. Hot junction is nothing but the hot environment to which it is exposed. Cold is ordinary room temperature. So the metal which has higher coefficient of linear expansion, in that direction the deformation takes place. So that is how the principle involved in bimetallic thermometer can be explained. Now we go into the details of this bimetallic thermometer. One end is fixed permanently to the casing, we have already seen that. The other end is secured to the pointer. Pointer moves over a circular dial. Bimetal expands and helical bimetal rotates at free end, thus turning the steam and pointer over a dial. So that means the pointer will swivel and it will show us the reading of the temperature. Now what are the advantages of this bimetallic thermometer? It is inexpensive, the cost involved is very less. It is applicable for a wide range of temperatures between -30 to about has about 550 degrees it can read. It is very simple, it is very compact, occupies a very small volume, it is very small in size and robust construction, it is very hard and rigid. Sensitive to smaller changes of temperature, it is another more or less one of the important advantages, that its sensitivity is to read even the smallest change in temperatures. Now where it is being applied, the applications of bimetallic thermometers. Switching devices using domestic ovens. So it is our usual day-to-day practice. Those who have domestic ovens, they can they can read the temperatures. Carwinkle lamps, refrigerators, the temperatures. Bimetallic metals, those are used in combination, can be tungsten and rhenium for high temperature applications, and copper and constantan for medium temperature ranges. Now we have a Bourdon pressure gauge for measuring the pressure. You can see the construction here. The threaded end is connected to the pressure side, where a steam or a particular fluid under pressure can be allowed to go inside. The metallic strip you are seeing there, it is made of a particular alloy, usually it is phosphor bronze, which is sensitive to even small pressure changes. It will tend to deform. So it is circular, which was circular now will take the shape of an elliptical shape after it is subjected to this pressure application. Now this kind of deformation inside a tube will be transmitted to the link, and through which it is given to the sector, and the sector will try to rotate the pinion. To the pinion the pointer is fixed. So this is how the pressure of the particular fluid like steam or any other chemical or whatever it is there, that will be transmitted to the tube, and the tube will deform, and such deformation or deflection will be transmitted through all these links to the final pointer. That is how one can read the pressure. So the Bourdon pressure gauge application can be understood like this. So it consists of metal tube of oval or elliptical cross section. The cross section of the tube is elliptical, bent into circular segment between 200 to 300 degrees. Tube is fixed at one end and other end is closed but free to deflect. So pressure difference, what is the pressure difference, tends to become circular. The cross section which was earlier elliptical now will transform into a circular one due to the pressure. So the increase in radius of curvature, naturally which was circular having some radius, the increase in radius of curvature also takes place, which actuates the tooth sector, and thereby it is being transmitted to the small pinion meshing with the tooth. A pointer fixed to the spindle of the pinion is moved. That is how this functions, and this particular movement of the pointer can be read in the form of pressure, which is in the calibrated mode. Now the deflection is large, it is simplicity and ruggedness. Pressures as has about 700 bar from 1 bar can be measured. Tube is made of phosphor bronze, which is a specially made alloy. Tube is made of alloy steel also for high pressures, which can read up to a value of about 6300 bar, and vacuum side pressures between 0 to 760 mm of mercury are also possible to be read with this kind of instrument. You can see just in the color form the Bourdon pressure gauge. The tube we can see which is in blue color, and the point at the links are shown in the green color, and the sector also, and the pinion in black color, and the pointer again. So the one is in brown color which is connected to the pressure side, and the pointer is given in red color. So this is how we can measure the pressures. Now the mechanical transducer. What is meant by a transducer? A transducer is basically a device which transforms the information from one mode to the other. Now we can see the details. A transducer is a device which converts positive displacements, thermal and optical signals into electrical quantities. Transducers are also known as prime sensors, pickups and signal generators. They employ electromechanical principles to convert the measured quantities into their analog form. So a transducer is simply a device used to transfer the information from one mode to the other, either from electrical to mechanical, or mechanical to electrical, or mechanical to optical, like that. What are the uses of the transducers? The elastic members such as diaphragms, like Bourdon tube, bellows, springs, etc. can be used for the measurement of different parameters. Now concentrated mass such as pendulum, manometric liquid, etc. can be used for the measurement of pressures. Thermal detectors such as bimetallic rods, thermocouple, resistance thermometers, etc. are also called transducers. Hydropneumatic elements such as floats, hydrometers, pitot tube, orifices, notches, turbines, etc. All these come under the category of transducers. Now we can see a mechanical transducer, how it functions. The applied pressure you can see, and it is connected to the bellow, the case in which is kept in a casing. The bellows are shown in the spiral form. The spring is there, and a connecting link is there which is connected to the sector. The sector is in turn in mesh with the pinion, and over the pinion the pointer is there. So whenever it is connected to the pressure point, so against the spring force the pressure is being transmitted to the bellows, and the bellows compress, which leads a movement to the sector, which in turn transmits the movement to the pinion, and then we can read the pointer. So what is the use of the spring used here? To read a particular range of pressures. Now the second, it is a bellow gauge. Now the pressure connection you can see there, and again spring form. It is as good as what I have explained in the earlier case. Through the pointer we can read the pressure. Now radiation and optical parameters. The hotness surrounding the furnace can be sensed by the instrument, and then it is transmitted to a particular suitable instrument, either in the form of voltage or current. It can be read, and further it is calibrated into temperature. Now we have pneumatic transducers which works on the principle of air. You can see here a platen on which A and B, the bellows are there. Pressure to be measured is transmitted to the bellow A, which swifts the beam on the left side, which creates an upward movement in the beam on the right side. Now on the right side there is an equipment, a pressure gauge G, it is air supplied there. Under normal conditions, the air passes through that gap, small gap you can see between the beam and the air nozzle, and that due to that certain pressure is recorded. Now what happens when the pressure is applied in bellow A? The beam will be shifted upwards on the right side, as a result of which the gap reduces, the air pressure increases, and such air pressure will again, the air will be pushed into the bellow B, which in turn pushes the beam on the right side down, and it is just to create a balance. But in the meantime, the pressure increase can be read. So now the beam has a pivot F. It is because of this pivot we can see the difference in pressures on the left side and right side. So in the meantime, before the balancing takes place, the pressure increase can be read in the gauge G. So this is only a mechanical or pneumatic transducer. Now the smoke detector, Mr. C.V. Subbarao now explains about the smoke detector.
So the smoke detector is used well before the fire accident or fire is going to be make its movement. That is, in general accidents or etc., it may be happen in such a case, but when the detection, that is a small amount of smoke is coming, that is we can identify or we can send that it is a smoke detector. It detects and gives the alarm so that we can find out that an accident is going to be occurred. So here what is happening is, it is not only total, it is not preventing, but it can well stop before further loss is being done. Now here it has to detect. Now let us see this particular figure. Here there is an ionization chamber. In this the total thing is going to be happen. Here if you see, this products of combustion is here, and here this ionization chamber is there. Here air is going to be sent and air is gets charged. So that why we are going to send air means, because it is the air is charged so that it can be electronically easily measurable, so that we are going to make it here. The irradiation will take place when in general conditions this is being given here, this positive and negative, because of the ionization this positive and negative electrodes are there. Between these two some current will pass, and under normal condition this capacitor is there. This is working under RC circuit. This capacitor under normal condition, this capacitor will be fully charged, but when the combustion of these things are entered into the ionization chamber, this nitrogen, oxygen etc. will enter here because of the smoke etc. When the oxygen has entered here or nitrogen etc., they are somewhat more dense, so that this ionization will be slower, and when this ionization is slower, this capacitor will not charge fully. Whereas under normal condition this capacitor is charging fully, but when this has come, because of the slower ionization, this capacitor will not charge fully. When this capacitor doesn't charges fully, here the charge detection Q is there, it is being locked. Because of this locking, here what is happening is, this integrating timer and resetting alarm times, these will be given certain sounds, that is through the alarm, and here we can preset the sensitivities based on that. When it is not it detects, it locks. When it locks, due to these time differences, this alarm gives us a caution. By seeing this caution, we can identify that a fire accident is going to be happen. This is how this smoke detector is used. This is based on the principle of ionization of the things, and air is used because it can be easily measurable, electronically easily measurable. And so today we have learned about what is instrumentation. So for an instrumentation we need instruments. Out of that there are lot of types of instruments, but we are limited to mechanical instruments as well as electrical instruments. Out of that we have seen temperature measuring devices, pressure measuring devices and smoke detectors.